Everyone, and welcome. I'm excited to kick off our session with today's presentation on the top 100 AI plus Java developer interview questions. This is the cover slide, so I just want to briefly introduce the topic. We'll be exploring some of the most important questions you might face in interviews for AI and Java development roles. Throughout this presentation, I'll cover key concepts, problem-solving strategies, and tips to help you prepare effectively. So, let's get started and dive into what's coming up. Let's start by understanding what artificial intelligence really is. AI refers to the simulation of human intelligence in machines that are programmed to think, learn, and solve problems. Moving on, what is machine learning? It's a subset of AI that focuses on enabling machines to learn from data without being explicitly programmed for every task. Now, it's important to distinguish between AI, ML, and deep learning. AI is the broad concept. ML is a specific approach within AI, and deep learning is a more advanced subset of machine learning that uses neural networks to model complex patterns. Next, we have supervised and unsupervised learning. Supervised learning involves training a model on labeled data, where the answers are known, to make predictions or classifications. Unsupervised learning, on the other hand, deals with unlabeled data, where the goal is to find hidden patterns or groupings. Then, there's reinforcement learning, which is quite interesting. It involves training models through a system of rewards and penalties to make sequences of decisions. Understanding training data is crucial because it's the foundation for teaching our models. Good quality, representative data helps our models perform well. We also need to be aware of overfitting, which happens when a model learns the training data too perfectly, including noise, and fails to generalize to new data. Conversely, underfitting occurs when a model is too simple and doesn't capture the underlying trend of the data effectively. Now, what exactly is a model in machine learning? It's essentially the outcome of training, a mathematical representation that makes predictions based on input features. Speaking of features, feature engineering is the process of selecting, modifying, or creating new features from raw data to improve the model's performance. All these concepts form the fundamentals of AI, especially as we aim to build smarter, more effective systems. Let's start by understanding what an algorithm in machine learning actually is. Essentially, it's a set of rules or a process that the computer follows to learn from data and make predictions or decisions. Moving on, a neural network is a type of algorithm inspired by the human brain, designed to recognize complex patterns and solve tasks like image and speech recognition. Next, we have datasets, which are collections of data points used to train and evaluate our models. Without a good dataset, our model can't learn effectively. Speaking of learning, model training is the process where we feed data into the algorithm so it can learn the underlying patterns. Once trained, we need to see how well our model performs, which brings us to model evaluation. This step involves testing the model on new data to check its accuracy and reliability. When we talk about accuracy in ML, we're referring to the proportion of correct predictions out of all predictions made. It's a simple but important measure. But accuracy alone doesn't tell the whole story, especially when dealing with imbalanced datasets. That's where precision and recall come in. They help us understand how well the model is identifying positive cases and avoiding false positives or negatives. To balance these two metrics, we use the F1 score, which gives us a single measure of performance that considers both precision and recall. Now, let's briefly address some common issues in ML. Bias refers to errors introduced by overly simplistic assumptions in the model, which can lead to underfitting. Variance, on the other hand, is about the model's sensitivity to fluctuations in the training data, often leading to overfitting. Understanding these concepts is crucial because they impact how we build, evaluate, and improve our machine learning models. They form the foundation for making informed decisions in AI development. All right, let's dive into what makes generative AI so fascinating and what's currently trending in this space. First, we have to understand what an LLM, or large language model, actually is. It's a type of AI trained on vast amounts of text data, enabling it to generate human-like language and understand context very effectively. Next, prompt engineering is a crucial skill. It's all about crafting the right inputs or questions so that the AI produces the best possible output. Think of it as learning how to ask the right questions to get the most insightful answers. Tokenization is another key concept. It's the process of breaking down text into smaller units, or tokens, so that the model can process it more efficiently. Without tokenization, understanding and generating language would be much more complex. Then we have transformer models, the backbone of most modern generative AI systems. They're designed to handle sequences of data, like sentences, and excel at capturing relationships within the text, which helps in producing coherent and contextually relevant responses. The context window is important too. It's the span of text the model can consider at one time. The larger this window, the more context the model can take into account when generating its output, which improves accuracy and relevance. Now, a common misconception is hallucination in AI. That's when the model invents information that isn't true or isn't based on the input data. It's a challenge we're actively working to reduce. Temperature in LLMs is a parameter that controls randomness in the output. A lower temperature makes the responses more conservative and focused, while a higher one introduces more creativity and diversity. Fine-tuning is another important process. It involves training the model further on specific data to make it more accurate or aligned with particular tasks or domains. And finally, Retrieval-Augmented Generation, or RAG, combines traditional retrieval methods with generative models. It allows the AI to fetch relevant information from external sources before generating a response, making outputs more accurate and informative. All these concepts are interconnected and form the foundation of what makes generative AI so powerful and trending right now. It's an exciting time because these advancements are opening up countless possibilities across industries. All right, let's dive into some key AI tools and platforms that are shaping the way we work with data and build intelligent applications. First up, we have LangChain, which is a powerful framework that helps us connect language models with other data sources and workflows seamlessly. It's all about making language models more practical and integrated into real-world applications. Next, there's LangGraph, a tool that focuses on visualizing and managing complex language workflows, making it easier to see how different components interact. Moving on to Hugging Face, which is a well-known platform offering a vast library of pre-trained models and datasets. It's essentially a hub for NLP innovation and collaboration. Then we have the OpenAI API, which provides access to some of the most advanced language models out there, enabling us to build sophisticated conversational and generative AI solutions. Now, a core concept in many of these tools is the vector database, which stores data in a way that allows for fast similarity searches, crucial for semantic understanding. Speaking of vector databases, Pinecone is a leading example, offering scalable and efficient vector search capabilities. ChromaDB and Weaviate are also notable options, each with their own strengths in managing and querying large-scale embeddings. Embeddings themselves are a fundamental concept. They convert words or other data into numerical vectors that capture their meaning, enabling machines to understand context and relationships. This leads us to semantic search, which goes beyond keyword matching to find results based on the meaning behind the query, greatly improving search relevance. Together, these tools form an interconnected ecosystem that empowers us to create smarter, more intuitive AI applications, aligning perfectly with our overall theme of harnessing AI to solve real-world challenges. Let's explore how Java can integrate with AI models and the key concepts involved. First, we have Spring AI, which is a powerful framework that simplifies connecting Java applications with various AI services. It provides tools and abstractions that make working with AI models more seamless and developer-friendly. Next, understanding what an AI agent is crucial. An AI agent is essentially an autonomous entity capable of perceiving its environment and taking actions to achieve specific goals. In the context of Java, these agents can be built to interact with AI models dynamically. Moving on, the Model Context Protocol, or MCP, is a way to establish a standardized communication framework between models and applications. It ensures that data exchanges are consistent and reliable, which is vital for complex integrations. Now, let's talk about RAG architecture, Retrieval-Augmented Generation. This approach combines retrieval mechanisms with generative models, allowing systems to fetch relevant information on the fly and generate more accurate and context-aware responses. A prompt template is another key concept. It's essentially a predefined structure or pattern used to craft prompts for AI models, ensuring clarity and consistency in interactions. This is especially useful when working with multiple prompts or complex workflows. Tool calling in AI refers to enabling AI models to invoke external tools or APIs during their processing. This capability allows models to access additional data or perform actions beyond their internal knowledge base, making them more versatile. Memory in AI agents is about maintaining context over interactions. It allows the agent to remember previous conversations or data points, leading to more coherent and personalized responses. Streaming response is a technique where the AI model delivers its output incrementally, allowing for real-time updates and faster interactions. This improves user experience significantly, especially in chat applications. Finally, understanding how AI chat architecture works ties all these concepts together. It involves orchestrating prompts, memory, tool calls, and streaming responses to create smooth, intelligent conversations between humans and machines. In summary, integrating AI with Java involves a combination of frameworks like Spring AI, protocols like MCP, architectural patterns like RAG, and features like memory and streaming responses, all working together to build powerful, responsive AI applications. Let's explore how Java can be integrated with AI, starting with calling an LLM API. You can use simple HTTP clients to send requests to services like OpenAI, making it straightforward to incorporate large language models into your Java applications. Next, we'll look at how Spring Boot integrates with OpenAI. Spring Boot provides a robust framework for building scalable applications and can easily be configured to connect with OpenAI's API, enabling you to add AI capabilities seamlessly. Then there's Spring AI, a project designed to bring AI integration into the Spring ecosystem more naturally. It offers tools and abstractions that make working with AI models more intuitive within Spring-based applications. Creating an AI chatbot in Java is also quite achievable. By combining API calls, natural language processing, and some conversational logic, you can develop chatbots that interact intelligently with users. Implementing RAG, or Retrieval-Augmented Generation, in Java involves combining retrieval systems with generative models. This enhances the AI's responses by grounding them in relevant data, making interactions more accurate and context-aware. Storing embeddings in a vector database is critical for efficient similarity searches. Java applications can interact with vector DBs to manage and query embeddings, which is essential for personalized AI experiences. Handling large AI responses in Java requires careful management of streaming data. Java's concurrency and I/O capabilities allow you to process and display extensive responses smoothly, ensuring a good user experience. Reactive streaming for AI responses takes this a step further by enabling real-time data flow. This approach ensures that responses are delivered progressively, making interactions feel more natural and responsive. Securing AI APIs is paramount. Implementing authentication, authorization, and encryption helps protect sensitive data and prevents unauthorized access to your AI services. Handling prompt injection attacks involves validating and sanitizing user inputs. This step is crucial to prevent malicious prompts from compromising your AI system's integrity. Bringing all these points together, Java offers powerful tools and frameworks for integrating AI effectively. Whether it's connecting to APIs, managing data, or ensuring security, Java provides a comprehensive environment for building intelligent applications. This integration is central to advancing AI-driven solutions within your overall technology strategy. Let's now explore the key aspects of designing a robust AI system. First, building an AI chatbot system requires careful planning around user interactions and ensuring it can handle diverse queries effectively. When designing a document search AI system, the focus is on creating efficient indexing and retrieval mechanisms to provide accurate information quickly. Thinking about how to build a knowledge-based chatbot, it's important to structure your data well and ensure the system can learn and update over time. Scaling an AI microservice involves strategies like load balancing and modular architecture to handle increasing demand without performance drops. Caching AI responses can significantly reduce latency and improve user experience by storing common replies for quick access. Reducing LLM costs is crucial, and this can be achieved through optimized queries and model fine-tuning to avoid unnecessary computations. Handling AI latency involves optimizing network and processing times, ensuring the system responds in a timely manner. Monitoring AI systems continuously helps identify issues early and maintain high performance. Versioning AI models is essential for tracking improvements and rolling back if needed, while deploying AI in production requires careful testing and integration practices. Overall, these points tie into the broader goal of building scalable, reliable, and efficient AI solutions that deliver real value. Now, let's explore some real-world AI use cases that are transforming various industries. First, AI in recommendation systems plays a crucial role in personalizing our online experiences, from suggesting products to recommending movies, making our interactions more tailored and efficient. Moving on, AI in fraud detection helps financial institutions identify suspicious activities quickly, safeguarding our assets and ensuring trust. In healthcare, AI is revolutionizing diagnostics and treatment plans, enabling more accurate and timely medical decisions. Chatbots powered by AI are enhancing customer service by providing instant support and handling inquiries around the clock. AI in code generation is making software development faster and more accessible, automating routine coding tasks and assisting developers. Document summarization uses AI to distill lengthy reports into concise summaries, saving time and improving information absorption. Customer support automation with AI improves efficiency by managing routine queries, freeing up human agents for more complex issues. Predictive analytics leverages AI to forecast future trends, helping businesses make data-driven decisions. Anomaly detection identifies unusual patterns or behaviors, crucial for security and operational stability. Lastly, AI in image recognition is powering applications from facial recognition to medical imaging diagnostics, enhancing accuracy and automation across many fields. All these examples highlight how AI is seamlessly integrating into our daily lives and industries, emphasizing its importance in driving innovation and efficiency across the board. Let's take a moment to explore some key concepts in AI security and ethics. First up, AI bias. This refers to the tendencies within AI systems to favor certain outcomes, often unintentionally, based on the data they are trained on. It's crucial to identify and mitigate bias to ensure fairness and equity. Next, responsible AI. This is about designing and deploying AI in ways that are ethical, transparent, and accountable, ensuring they benefit society without causing harm. Data privacy in AI is also vital. It involves protecting sensitive information and maintaining user trust by implementing strong privacy measures and complying with regulations. Prompt injection is a technique where malicious inputs are crafted to manipulate AI responses, which can lead to unintended or harmful outputs. Addressing this helps safeguard AI systems from manipulation. Adversarial attacks are another concern. They involve intentionally designed inputs that deceive AI models, compromising their accuracy and security. Protecting against these attacks is essential for reliable AI deployment. AI governance encompasses the policies, standards, and oversight mechanisms that guide responsible AI development and use. It ensures that ethical principles are upheld across all stages. AI safety measures are practices implemented to prevent AI systems from causing harm, whether through malfunction or unintended consequences. These are fundamental for trustworthy AI. Model alignment refers to ensuring that AI systems' goals and behaviors align with human values and intentions, avoiding scenarios where AI acts in ways we don't expect or want. Ethical AI is about embedding moral considerations into AI design, development, and deployment, promoting fairness, accountability, and respect for human rights. Finally, explainable AI focuses on making AI decisions transparent and understandable, so users can trust and effectively oversee AI systems. All these elements, bias, responsibility, privacy, security, and ethics, are interconnected. They form the foundation for developing AI that is safe, fair, and aligned with societal values. Recognizing and addressing these aspects is essential as we advance in AI technology. Let's explore some of the more advanced concepts in AI. First, fine-tuning versus RAG. Fine-tuning involves adjusting a pre-trained model on specific data to improve its performance for a particular task. Retrieval-Augmented Generation, or RAG, combines retrieval systems with generative models, allowing the AI to access external information dynamically. Next, model distillation is a process where we compress a large, complex model into a smaller, more efficient one, retaining most of its capabilities. Moving on, multimodal AI refers to systems that can understand and process multiple types of data, like text, images, and audio, all at once. AI agents are autonomous programs that can perform tasks on our behalf, often making decisions based on their environment. Autonomous AI takes this a step further, operating independently without human intervention, often in real-time scenarios. Chain-of-thought prompting encourages models to reason step by step, leading to more accurate and logical responses. Function calling is about enabling models to invoke specific functions or APIs to perform tasks, making interactions more dynamic and practical. AI orchestration involves coordinating various AI components and systems to work seamlessly together, ensuring smooth workflows. Observability in AI is about monitoring and understanding how models perform in real-world settings, which is crucial for reliability. Finally, AI infrastructure encompasses the hardware, software, and tools needed to develop, deploy, and maintain AI systems effectively. All of these concepts are interconnected, forming the foundation for building more sophisticated, reliable, and capable AI solutions. Let's take a moment to focus on the key points we've covered so far. First, what is RAG architecture? It's a powerful approach that combines retrieval and generation, enabling AI systems to access external knowledge bases to produce more accurate and relevant responses. Next, what exactly is an LLM, or large language model? These are sophisticated models trained on vast amounts of text, allowing them to understand and generate human-like language. Moving on, a vector database is crucial in this ecosystem. It stores data as vectors, making it efficient to perform similarity searches and retrieve relevant information quickly. Now, how does Java fit into all this? Java integrates with AI through various libraries and frameworks, enabling developers to embed AI capabilities directly into their applications seamlessly. Prompt engineering is another vital concept. It's about crafting the right prompts to guide the AI to produce the best possible outputs. Then we have Spring AI, which is a framework that simplifies building AI-powered applications within the Java ecosystem. Embedding, on the other hand, refers to representing words or phrases as vectors, which helps in understanding and matching similar content. Another critical point is hallucination in AI, where models generate plausible-sounding but incorrect or fabricated information. Understanding the difference between fine-tuning and RAG is also essential. Fine-tuning involves adjusting the model itself, while RAG leverages retrieval to enhance responses without modifying the core model. Finally, designing an AI chatbot system involves integrating these components: RAG, embeddings, prompt engineering, and the right architecture to create a responsive, accurate, and user-friendly experience. These concepts are interconnected and form the backbone of modern AI applications, helping us build smarter, more reliable systems. Want the answers? Well, I've got you covered. I will be explaining 10 AI interview questions every single day. That's right. Every day, you'll get a detailed explanation of each question, so you really understand what's being asked. We'll also include Java and AI examples to make things clearer, and I'll share real interview tips to help you succeed. Day 1 starts tomorrow, so make sure you're ready. Subscribe and hit that notification bell so you don't miss the next video. This is all about preparing you step by step for your AI interviews. So stay tuned, and I'll see you tomorrow for the first question.